Okay, what we're going to be looking at here is a heliocentric solar eclipse. Or what I have out here modeled is the basic solar system, at least what's relevant in the context of the solar eclipse. So we have the sun, we have the earth, and there's a moon, and the moon. Now we have the sun here, the earth's over here. So I've given a rotational period of 23.9 hours. That's how long it takes for it to make one spin on its axis. This Earth is about 1 AU from the Sun and has an orbital period of 1 year. So if we zoom in on the Earth, you can see the Earth and Moon here. Showed you the Earth things, but look over and look at the moon here. See, it's got a rotational period of 27.3 days, as well as an orbital period of 27.3 days. It is 384,427 kilometers from the Earth. Okay. So now we have the setup of what's going on here. Now how these objects are moving is the Earth, at least looking down on it. This would be its North Pole up here, its South Pole's below. Okay, the Earth's going to spin in an anti-clockwise direction in this direction here. The Moon also orbits anti-clockwise, same direction like that. The Earth, about once every 24 hours, is spinning. The Moon takes 27.3 days to do this long orbit. Okay, the question here is what direction the shadow is going to go. A lot of people have this idea in their head that the shadow would progress the same direction they're seeing the moon through the sky. As the Earth is turning this direction, the moon appears to move westward for the observer, just as the sun does. However, does that mean the shadow will move westward? That's the question. Now, what most people, of course, have been hearing people say is, well, it'll move eastward, but they don't believe it. They think, no, 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 no. The moon's period's longer, therefore the shadow could not move east. It has to move west. And unfortunately, that is simply not true. So we're going to start the simulation and see what happens here. Currently, as the setup is going, I have the time set, so about 20 every second in the simulation is 20.8 minutes. Okay. So when I start it, you're going to see this Earth spin west to east. So you're going to see it go, you're going to see that Africa, for example, you can see Africa here. It's going to move across in this direction. The moon as well will be moving in this direction, but you're not going to see it move much. And we'll just watch to see what happens here. Okay, let's start the simulation and see what the shadow does. And there you have it. You watch the shadow progress from the west to the east, moving faster than the Earth's spin. We zoom out, we see the moon has moved. A bit. However, you notice it's not that much. It made a very small arc, but the shadow has moved. And you can see what it's doing here. Now the reason isn't doing it is if you look here as it transits the Earth, example here, you'll watch the moon cross the Earth faster than the Earth spins. So watch it. Now the reason that has happened is pretty simple. If you look down at the Earth, if you look down on this system from above, we'll say it's parallel like that, and we'll say the sun's down here. Okay. The Earth is rotating this direction. The moon is orbiting in this direction. However, the Earth is very small, very, very small, comparatively to this large distance as far as the radius of the moon's orbit. So at the equator, the speed is from this spin is only 1,700 kilometers an hour. The moon, on the other hand, as it's doing its orbit, the speed here in this direction is 3,700 kilometers per hour, much faster. Now, as the moon shadow is crossing across the Earth, it's a ray from here back. back away from the sun. It has nothing to do with where the Earth is or what its spin is, which means the shadow is moving across the Earth like this, directly parallel to wherever the moon is. And that's how it crosses. It's not an arc, it's not centered on the Earth. It doesn't follow like 8 degrees per second in that context. It's purely based on this ray basically going across the Earth. And that's why the shadow moves so fast, because the moon's actual velocity is faster along that tangent. And that's why it works like it does.